Yeah, I'm not turning on the camera since I'm recording, so that your privacy is respected. But they can see the slides as well, at least they cannot see it online. And so the goal for today was to introduce design patterns. The last 3 lectures or 4 lectures, I don't know how many they are, but my idea was to give you a primer on design patterns, how to implement them in Python, why they're useful, give you some literature, and that's it. I thought about how to introduce the topic, and there's basically one option, which is go through them and pretty dry, like what they are, how they're used, and make examples. Like that I wouldn't like it. So I decided to go the other way around, take a problem and try to solve it. So try to design the solution to this problem and see how the design pattern can be useful in doing this. So the problem that I decided to take is designing an application framework. So your goal is to create a set of widgets and a layouting system and a rendering system so that you can design a UI with simple requirements, so no fancy stuff like tabs and so on, but just buttons, labels, text inputs, and a table view so that you can show data, and a responsive layout. So, and I foresee that the first part of this lecture should be actually designing together this and trying to understand where we should go with the design. And then we will tackle each problem after the other in the next 3 lectures and see how this is implemented and how the design patterns look like. So before we started the design of this, any of you has had heard or used declarative UI frameworks like React or Swift UI or anything like that? So do you know already what the difference is between declarative and imperative UI design? All right, let's introduce this part before we start the designing of the actual framework. So basically, why did I do this? It should have been just one go. So basically, imperative design is I define what my interface looks like. There's a button, there's a text box. Then when somebody clicks on the button, I toggle the text box on and off, right? So somebody clicks on it, activates the function, on click, I go through my document object model that would be in HTML or my class for the object if I'm using any other framework, and I took the object within this class and I just deactivated or activated. That would be an action driven by a button. Now in declarative UI, you don't do this. Instead, you define that on click, there is a certain state variable that gets changed. And is this editing or not editing? It's a Boolean within your state. And when you draw the interface, you actually do it considering the state of the application. So you basically, every time there is an action, you redraw everything, and then you check if the state is editing, then I show the text box. Otherwise, I don't. Any comment or consideration? What do you think about this approach, the first and the second, before we move on?
So on the left side, the state is kept as a property of the text box.
Of the UI widgets,
UI
yes.
element. And on the right, it's a self-defined state variable called editing.
Yes.
And I use this state variable to then modify the draw function.
Exactly.
Okay.
What would the advantage be on one side or the other? What do you think? Any latent flows in the design on one side or the other that you can see?
Keeping state in one place or in multiple places. Maybe this could be one of the differences.
That's one of the differences, yes. And the reason why this came to be, because it's something pretty new. I mean, 2013 was the first declarative UI, and now Google and Apple are moving to declarative UI in their native APIs, but it's not yet settled. I mean, many still use imperative UI for most of the programming. The reason to go through this was exactly because of that, having one place where the state is kept for everything. Because otherwise, you run into complexity problem. This is one of the problems with imperative UI. I'll show you exactly But there is one big flaw in Declarative UI, which you should see right now. Every time I change a state, I have to redraw not just the button, everything else as well, right? So performance. I have to redo layouting, I have to redo drawing, I have to redo everything. I cannot cache, in principle, here I'm just changing the thing that I'm interested in changing and I have control. Here I don't, because I don't know how the drawing will use my state. I completely decouple the state management from the drawing at the expenses that of course the drawing doesn't know about what I did with the actions, and therefore it has to recheck everything from the start. Right? So if it's not implemented well, this is incredibly slow. We will implement this way because we want to do something interesting. This is pretty easy. So we will do the implementation on the declarative side, and we'll see also how we can tackle the performance problem while we get to it. But before we actually can tackle the performance, and then that's the first pattern, which is not actually a classified design pattern, but it's something that is very important to learn. So before you tackle performance, the code has actually worked, because otherwise nobody cares about performance if it doesn't work, right? So first we'll do it without the performance optimization. So now that we know imperative declarative difference, let's check how does this work in theory. Basically, in the imperative system, you have a user action, which calls a delegate. Usually there's three objects that you have in the typical MVC architecture or other similar architecture. You have a controller, which is basically managing the workflow of the application, like activating stuff, deactivating stuff, managing data, bringing data from the model to the view, and back actions from the view to the model, and so on. Then there is a model which is just there to give you access to your underlying database or data structures or whatever they are, and maybe logic as well. There might be business logic inside here. And then there is the view, which is just generic widgets, properties with some way to transform your wish into stuff, pixels on the screen. That's the only work. There should be no business logic, no control logic inside here. So when you are in a typical imperative programming structure, you have four steps. If the user takes an action, you pass it on to the delegate method on the controller. That's like on click for a button, right? The delegate method knows what to do with the model, does the update of the model, and then basically it changes back the UI to reflect the model changes, right? And it does this in a very specific way. And the flow of the information goes this way, right? Back and forth. In the declarative way, you have a circular update actually, because your user action has a delegate as well, but the delegate changes the model and doesn't do anything to the UI anymore, right? The UI is regenerated then completely from the model. So that's basically the step that you have. So you separate the going from the action to the model and the going from the model back to the screen in two completely different decoupled pieces of code. And this is the advantage. Which advantage it has? In the imperative system, you have performance and as pros and cons is complexity. Why? Because if you have 5 buttons, you can click those buttons, 5 different, in 125 different orders, right? So, and if you change the individual states in the widgets in these 125 different orders, you possibly run into problems because changing one state take for granted assumes that the other state is in a certain variable, a certain state. And if it's not there, it could be a bug because you assume that when somebody actually clicks on the text box is activated. But it couldn't. It could also be not activated for whatever reason, because you forgot to activate it in encoder, because whatever, and then it crashes, right? Because it tries to access something that is not there. The order of difficulty of this is n factorial. If you assume that you can press one button only one time, it's n factorial. Otherwise, it's actually higher. So, and who has less than 5 interactions objects on the UI? Almost nobody. You have many more. So you run into this complexity. And if you program the UI for a few years, like I have, you know that this is actually your problem. Like UI is one of the most buggy pieces of code you can write because of exactly this. Because people forget that, you know, you have to be careful when deallocating widgets or changing the states when somebody presses the button and so on, and then nothing works anymore. You don't know where to find the bug because of this complexity here. And nobody is able to go beyond 100 different orders of states. Let's say 20, but I want to be, you know, magnanimous here. So this is the problem with imperative programming, and this is why we do declarative programming now. So now let's go back to our requirements, and let's see how do we want to design this. Any idea? Where should we start? What's the first thing that comes to your mind? If this was your problem and you have to solve it, where do you start?
Responding to window size changes.
Correct. Let's say before responding to Windows size changes, Windows size. So I have a starting window size. How do I deal with it? And so what do? I have a window size, let's say 100 by 600. I have to place some buttons. How do I tell my widgets where the buttons should be? That's the first question. I want to design an application. How do I say I want a button here, I want to have a text box here? How do I organize this stuff together?
With relative position to the window position.
So you could have like top, you know, plus X and something like this.
Right minus X and so on. So
right. So you can put relative positions. That's one way to do it. Yeah.
Also, at least to a certain degree, relative size.
Relative size. So you could say, okay, the size of the widget size is width of the window divided by some number. Okay.
Also, the X divided by some factor. So.
Right. So what happens when you resize the window?
you have to redraw.
You have to redraw, but how do you make sure that this stuff is consistent? Because if you say, okay, this is like X plus 10, and then the width is like 1/5 of the total width, but then I have another button.
You have to,
And
to define an order, like with.
Okay, so put the widgets in order. Widgets, we're getting there, right? In order, and then
Recompute the position.
recompute the position. So the positions are not given, but I actually computed. That's a good idea.
I mean, if we have relative, it depends what system we have. If we have relative positions like the +10 button is right to the +1 button, then I need to start somewhere, and it depends on my layouting engine. I mean,
exactly. So the layouting engine is what we're designing, right?
Yeah.
So how do we want to design it? Put the widgets in order and compute the position is a good starting point. Yes.
Also, probably define the ones that are relative to the window, and then first, and then the ones that are relative to each other in some sort of order, so we know which one to draw first.
I'm looking for a data structure. Before we even sort the details, right? What you want to do is organize your screen. Like, what should depend on what and who should do what? Is it a list that we're looking at? Is it a grid that we're looking at? Is it, what kind of data structure do we want here so that we can organize this without knowing everything at once in one single place and do all the compilation there? Because this is really hard if you do it like that. I mean, I tell you, I have like these 4 cells, I have this text box, these buttons, and now organize it, right?
Probably a directed graph with some sort of step block that different branches are not like running away from each other.
A tree.
Yeah.
Easier. All right, so a tree is what you want. You want basically a toolbar right here, which is its own element, and it then organizes stuff inside the toolbar, disregarding everything else, right? And then you want the table here that organizes the stuff, the cells within the table, and within the cell, you don't want to know about what's outside. You want to organize the stuff inside the cell, and so on, right? So one of the things that everybody is using is basically vertical and horizontal container. As stupid as that, right? You put things in rows or in columns, nothing else. There is one problem though. Who tells me that the text box should expand and the buttons shouldn't when I expand the window? How do I decide that?
Well, widgets could have like a fixed size or a variable size, basically.
Okay, so variable
At least in
Fixed.
1 dimension.
fixed, but then again, what if I have a label, a text box, and a button? What if the button has some long text inside it? It's not really clear cut where I should expand and where I should not expand, or where I should actually compress or not compress, right? Because this is a different story. So
wouldn't I also need like a minimum window size in order to not get like buttons crushed and stuff like
you could decide to enforce a minimal window size, absolutely. So after a certain resizing event, you just block the user. It cannot be resized beyond that. Yeah, absolutely. An idea that I'm going to steal from other widgeting systems is that you could tell each widget what's its compression resistance and what's its arcing force, so that you can actually scale. You know, if you have something like a text box, you want it to be very compression resistant vertically. That shouldn't crash your fonts out of the screen, right? But in this direction, it's fine if it actually gets compressed a bit more, right? On the other side, if you have space, you use it, all of it, right? So hacking force is very low. For the button, it should be higher, right? Because you don't want buttons like this, and so on. So we can define compression resistance, arcing force to deal with the internal structure of a container. What happens if I put a container inside a container?
Nested calculations. I need to resolve the properties of the inner container, then go to the outer container, but the inner containers can modify each other.
All right, we have a structure coming in, right? Container, and then you have a button maybe here, another button, and here we have directly text input, something like this. So I first have to consolidate. If my upper container asks me, what's your compression resistance here? So, right, it asks me, what's my compression resistance at this level? Now, what should I do? What should I tell it? I have two buttons inside.
Ask the buttons.
Ask the buttons. So what's your resistance here? And the buttons tell me, well, it's like 700. So since I have only buttons, I can assume it's 700. What if I had a button and a text box? And the text box is like 500 and the button is 700. What should I give?
The minimum?
Maximum.
The minimum up to a certain size and then the maximum. So it's not easy, right? I mean, you can take a level 0 approximation and say I should give the minimum so that the text box gets squished first. And then when I reach the buttons though, I'm actually already too far because I don't see anymore anything of the text box. So I don't care. But the point is, this is actually not that easy, right? This particular thing. Also, I could have an horizontal container and a vertical container. And now things are a bit difficult because I am actually dealing with something that is slightly different. The vertical container must has the vertical resistance and then pass it as horizontal and so on. Anyway, this is an interesting fact, but it's really a detail. The point is, in all this structure, I'm doing something before I even get to that, right? Before I even get to the compression resistance, I want to ask these guys how big they should be, right? So the size should be decided by the content. If I have a button and I put a label inside it, the label should actually tell me that the button should be at least this size, so that I can just put the label in without caring how much the font is and that the button is rendered properly. So the first thing that I want to do is ask these guys, size, what's the size that you want? right? And then consolidate it up. Once I have this number, then I compare it to the window size, and then I decide how to squeeze and stretch and do stuff to my first level of content. And that should be done again at the next level, and so on and so forth, right? Does that make sense? This is actually the first design pattern that you'll see is actually two already. One is the composite and the other one is change of responsibility. And the trick is that once I have put text and container at the same level, that's actually a very nice structure that I'm using here, because I'm treating a collection of items the same way that I'm treating a single item in my structure. And that means that this container must fulfill the same interface as the text input. Right? The container must be able to draw itself, to lay out itself, to do everything that I want. If I have a click event, or if I have any other thing that I want to pass it down the tree, I need to be able the container to do the same job as the text input, right? It's called composite, and it actually solves a lot of problems. Whenever you have a structure where you have to organize itself, this is the one thing you want to take every time. And the second part is the chain of responsibility. So I'm passing, I have a big job to do, layout in the old window, right? And I'm passing it through the tree in such a way that each part of the widget basically does its own part of the work. The same I can do for the draw, right? So when I go and actually I say draw now with this, I mean, I've done the layouting, I know the size that that the next level should be, not that each level, that the next level should be. Then I go and I say draw, and I give it width and the height and X and Y, right? And then the container will do its own job of layouting the stuff inside it with this given space and giving the draw issues to each leaf or each other container inside that container, and so on and so forth. So again, I am distributing the job to each little leaf in my tree, right? This again, it's very useful not only in UI, but it's useful everywhere where we have a tree structure of data that needs to do job on it, and you don't want to like think about it from a top-down perspective and do everything in one single function, considering the data structure as a whole. Instead, you want to distribute the computation through each element and follow the structure, follow the graph, right? So in this case, you would have, for example, here, a horizontal container containing then 3 buttons plus the text box. The text box itself is actually another container, which is an horizontal container with a label and the text input itself. And then you have the cells here, which are actually in a table view, and they contain a bit of a more involved structure, which we'll see probably next time. But inside the cells, there are an horizontal container and then 2 vertical containers, one on the left, one on the right, right? And here you actually see is a spacer plus a text label, spacer plus text label, so that it aligns on the proper side. I try to, we'll see the implementation, I tried not to use too many internal structure in the widgets, but actually use more widgets so that you could see how to combine them and what's the advantage of using that. You can always then put them together. So that is composite and chain of responsibility. By the way, if you are interested in the subject, there is an excellent book, which is basically the book on design patterns, which is by Gamma Helm Johnson, who's a former colleague of Marco at UIC, and Lycidas. Fantastic book, is on C++, not on Python, but the concepts are the same. Now, next order of business. Now, a button comes with a background, a border, and few other like modifiers if you want, right? But the same goes for a text input. Same goes for actually a container. I could put a border on top of the container, why not? So I don't want to reprogram the border for every single widget that I'm programming. How do I do it? How do I go about this? Any ideas? Also, I want to keep like a standard way to add border to a widget.
You come up with standard properties that you inherit in your tree with the default object model.
So I could use basically object oriented, right? I could say that this base widget have this border, draw itself with this border, and so on. Yes.
Or at least provide the same interface for the rest.
It's a valid approach. It's not the one that I would like to take because I want to have basically the possibility to add, and that's the basic requirements why I want to take this. I want to add the possibility to add a new property without touching the base model. Right? The idea would be, what if I wanted in the future to have, for example, a fancy mask that is not a border, does other stuff on top of the existing widgets? How do I add it, right? And the second, I mean, and then there is the question of supporting how you actually go on and modify the widgets when you write the UI, which has to be solved. So in this way, it's simple. You just add a property, so it's very simple. You put in the constructor. But if you want to do what I want to do, so actually adding dynamic modifiers later on without touching the base model, how do we do it? Any idea? So if you were to follow standard use object-oriented design, if you say, I have a interface widget, okay, and I want to do something and add some modifier, for example, border, with the properties of the border. And this must be supported by all widgets, and not only by border, but by all modifiers that I want. How would I do that?
I could create a function taking anything I want to add or modify, and
Right?
try to make it as universally applicable as possible.
So the function that you say is the visitor part. What you want actually is a typical visitor-visited pattern where the visited object is your widget and the visitor is the modifier. You have a common interface that basically every widget implements, which is visit, and it takes an instance of a visitor. The visitor is your modifier. So this basically is nothing else as opening up the internal model of the widget to the visitor. And the visitor can do within here whatever it wants. There is a smarter way to do it in Python because we are not bound to object-oriented. We have meta classes. So what we can do is actually cut the middleman and do this with meta classes so that every time that I write a visitor, the visitor gets registered within the meta class in a list. And it produces a new method on all the widgets which has the same name. So basically I can support stuff like button dot border and pass the border properties here without ever changing the button class or the superclass or anything else. The only thing that I do is when I register the class border here, the modifier must have a meta class which actually keeps all this variable. And in the button, I have to implement a method. You remember which one?
Set.
Get attribute, right? So that whenever the lookups of the dict of button fails to produce a result, it will check in this method. And in this method, I go to my meta class. I check if this class exists with small case as method, and then I return as object the class that implements the modifier. Is that clear? How do we use meta classes to implement this? Right? So start from the beginning. Meta classes are classes for classes, right? You remember? It's basically what instances a class. It's a meta class. It's a subclass of type. So when I implement my class border, and I say meta class equal to modifier, for example, this will call, when I declare it like this will call on modifier, new, init, and so on modifier, on the meta class. Like when I instance border, it will call new and init on border. So, right, I'm now instancing a modifier. The modifier in init, it can do the following. It can basically have an internal list like modifiers, and do like this as CLS, as or name, something like that, name. It's a string actually. So what you can do is just modifiers, append. We'll look at the real code. I'm skipping a lot of steps here. Append name. So now inside modifier, I know that there is a border. And once I know that there is a border, in widget, okay, in get atr, what I can do is if name in modifiers, right? Then return the appropriate class, which is this one in this case, because I match the name to the class, I generate the class dynamically and just return. And so I can implement this method border without ever touching the object. So in the future, if somebody wants to implement a new modifier, a new effect, a new whatever filter on your objects, shadow effects and so on, they just write their own class completely independently for your base library. They don't need to have access to your library repository or do anything in there. So, and this is quite useful because it keeps all the code decoupled, right? And this is, well, this is a Pythonic take on the visitor pattern, if you want. So now we have borders, background, I mean conceptually, right? Borders, backgrounds, and all the stuff like padding, it's the same. What about actions? What about clicking? Or scrolling or anything like that? How would you organize that part of the code? So there's two things about this, right? The first one, you have to give the possibility to a widget when it's implemented, not in the code of the widget, but when the user uses that widget to tell you, if you click on this, do that. So you need an interface for that. Right? I say basically button, right? Inside my layout, I have some button here. And what I want to do is on click and then call a function. And I tell you the function, right? That's what I want. And this function is mine. It's outside of the class, it's somewhere, it changes the model, does stuff, I don't know what. But I want this interface. How do I implement it? It's a modifier, right? Same. I just need to use the same method to implement the onClick, the same way. But then it's a particular modifier because I need to be aware of the clicking, and the clicking comes from the window. The window has the event, and it tells me where the mouse was and that the event happened. And then I need to pass it along the tree. So if this is my root element, my root container, then I have some container, button, text. And this is the button that I actually pressed. How do I know that's the button that I pressed?
I need to go down the root from top to bottom and check which container is affected.
Right, so I go here and I check what?
X, Y, and the sizes.
X, Y in between basically top, left, and bottom right, right? This is basically what I do. If it's false, I just go back, say no, I don't care. If it's yes, then I go down the tree and I do the same again and again and again. And this must be done in the base element of the widget. It's no way around. You don't want to do it in the modifier. You cannot do it in the modifier. You need to do it in the base element. So support for events has to be bred in the base widgets. But then again, the events themselves, they can be actually scalable. You can have multiple events, right? And using the same infrastructure. You could have click, you could have drag, you could have double click, whatever. They can use the same infrastructure that you design for the click itself. Anything else missing? Let's see if we can get to some of the code. So we have the click, we have the layouting. I mean, the draw is a technical thing. I mean, at some point you have to actually take the model and transform it into pixels. We're going to do it in OpenGL, but it's not part of this lecture. So I'm going to provide that. But for the rest, I think we have most of the things that we need to start. Then we can see each time how the details fit in. So, quick recap. Let's go do this as well. Let's go back here. So, quick recap. Composite. Using basically container and objects in the same way. I'm exposing the same interface to different, to container and to leaves in a tree structure. This is what the composite is. Question on this, is it clear before we move on? Chain of responsibility, same story. But this time we're passing an action, we're passing a command, if you want, an encoded action through the tree structure, and we're basically asking everybody, and the one responsible for it will actually pick it up. All right? So, and this is something that you use again and again. When you have composite, you always use this pattern as well. Visitor, also very important. So what you want is you have a common interface for modifiers and for widgets, so that you can add any modifier to any widget, and the right thing will happen. What you do is basically you just keep the whole thing here, use meta classes, and you add directly the method on top of the widgets, right? We'll see. I think we'll start with this for the code, and then oh yeah, we didn't talk about this. Yeah, we'll see later why it's important. But when you have to draw widgets, usually there's a few things that are common to every widget. Like for example, you might have cache this widget, and you might want to use that cache. If it's a button, a label, or a container, there's no difference in the code that does the caching, right? But then if the cache is not there, you might want actually to draw its own content. This is totally different for each widget, completely. So what usually you use in these cases is you write a method, which is only known by the internal interfaces, which is draw, right? It draws the whole element. Do the internal stuff first, and then you call another method, which is not implemented in the base class, which is draw content, which actually is specific for every widget and draws its own content if needed. So only if needed, you're calling this. This is the template method. It's used a lot to simplify stuff that should be common and specific, so that you can basically set up a set of steps that you need to implement in your own code, but I'm implementing for you all the basic stuff that goes in between, right? So we'll see that in action as well. These are the 4 design patterns I wanted to show you today. I think we'll use also tomorrow, the next week for most of this stuff. So let's start from the modifier. Let's see. I'm going to move this guy a bit so you can also see it. All right, so let's start with a simple one. Actually, start with modifier protocol making. which is just an implementation of this. So this is the meta class modifier. And as you see, it does really something very simple. It takes, when you init a new modifier, it first creates the type by calling super. This calls type, basically, and creates a new class for you. And once you have created a new class, what it does is just adds the name of the class, lowercase, to my list of modifiers. And that's it. That's all it does. So now I have a dictionary where I can pick my modifiers if I need. Right? It's clear what this goes down, right? It's very simple. Now, this gets instance, for example, nope. I need to go back to modifiers, sorry. So this gets instanced once when you are here. So when the interpreter comes here and sees class backgrounds, it calls the meta init and adds background lowercase plus the class to the dictionary, right? It gets called once per class, not once per instance, once per class. That's why it's important for us. So now, when you are in the UI model, in our widget, which is called, in this case, let's go through this quickly. Modifier method, there's UI element here. So when you are in the widget itself, what happens is, okay, you're calling something else like draw or any function that's actually implemented in the widget is going to call that function. But if it fails, if it doesn't find a match, it's going to call this method, getAttr. And be careful, there is a second one, which is getAttribute, and this will override all of your functions. It always be called first. So if you want just to be a catch-all at the end, you have to implement getAttr. It's a different interface between the two. So what this does is actually a bit of code, but what it does is basically checks for modifiers in modifier meta, and then returns that class as a return of the function that you call, right? Is that clear? So you call border, for example, lowercase, with some arguments, args and qargs, okay? What this thing does, if you call border, border is not implemented. It goes through here, checks that there is a border uppercase class as modifier. It takes this class itself, and then creates a wrapper function that passes your args and qargs that you call border with, right? And inside this function, it instantiates this class with the same arguments and keyword arguments and returns an instance of this class. Make sense?
So basically, there is, you call any function and then it goes down or upwards until it creates a class, and in the end the class functionality is delivered in the function. Is it that way?
More or less. All right, so I have my list in modifier meta, okay, mod meta. And this is a dictionary, and I have border, and then I have class border inside.
Yeah.
And then I have background, and then I have the class background, and so on. Right?
Yeah.
So this is my dictionary inside modifier. Now I have my widgets, right? And I call on it border. And I call it with border color equal red, for example. Okay, whatever that is.
Yeah.
It's be a constant. Now, what happens is it first goes into the class widget. It does the standard lookups. There is no method border. There is no field border. It then goes to the object itself. There is no local field border either. There is no variable that I assign to it. Once it's done there, then it asks getAttr. It asks getAttr and say, yeah, I got border here. What should I do with it? GetAttr border. That's what it passed, the string border. So what this method does, it goes back here, checks is border inside here. Yes, and take this. And now I'm going to do the following. I'm going to create a function, def, right, that returns border color red. That's all it does. So when you call it, this whatever function it is, this is now border basically. This is your border function, right? It's being dynamically created for you. Well, it returns an instance of the class border with the argument color equal red, right? That's what it does. Now it's your job inside this class to implement whatever you want for your widgets.
But is the class border or like is it created every time I call widget.border?
The class itself, no, the class is
No,
instantiated.
no, I
on-
mean the object.
The object, yes, it's a new object every time.
So I
So
don't.
this we call your init inside border when you call the function border,
Okay.
right? The constructor.
Does it make sense to cache this information?
Absolutely, but not at this level, right? At this level, the point is about declarative UI is that you have to think that everything is actually generated at runtime every time. And once it works, then you have to find a nice way to cache this information so that it actually does.
Okay.
Right? Because that's like when you pass everything by value. It has this value, pass it by value, but it's also very expensive if you don't use pointers. Right? It's the same story.
I totally get it, where there is more than a factor 1,000 slower than object-oriented programming.
Yeah, it is. It is. So you need to, this buys you laziness in checking all your cases at the cost of performance, because then you just basically, you throw down the UI, you know that everything is going to work because there is an if the state is A, then it goes here, if the state is B, it goes there. So nothing can go wrong, right? It's not like you're changing the internal state in some nasty ways. But again, you have to redraw everything every time, which means reinstantiating your object, redoing layout, redrawing everything, and so on and so forth, which is a big mess. All right. So, but now, before we get into that, so this is the modifier, and now I have this object border. And what is a border? Now, what do I pass here? The first thing I want to pass is actually what should be a border of, right?
Yeah.
So, and that is for free, because this is a method, so this is self. Self is a widget instance. It's okay. But I actually want to do it a bit better. Instead of modifying the object itself, I want to keep it separated. So the border, at the end of the day, is a container, right? A container with only one element. And it might be from performance reason actually another blob to add into, that is actually makes sense because it has a different range of drawing. So if I have a border and the border has like 2 pixels width, well then I need to draw with X and Y and W and H here. But inside I have X plus 2, Y plus 2, and W minus 4, H minus 4, right? So I need to keep those two separated. So the best way to do it is actually, let's consider it a container, forget about it, pass the element that's inside as argument, so it's not self, but it's actually element inside, right? And that's it. And then I draw around it, and then I pass the draw to the element. Done.
And the widget then gets in, like in the tree structure, the widget gets a new child basically, which is then border, and border is contains.
Other way around.
Yeah,
Right?
no.
So the
Yeah.
border contains the widget and so on.
Okay.
And actually I could have here another background and padding and so on. They're all
Yeah.
containers
Yeah.
basically. I can structure them all as containers. Now this might not be the best or most efficient way. I'm gonna do this because it's going to be the most interesting to implement, all right? And you could say, okay, what happens if I switch around background here or background here, right? And what's a consistent way to do this? What happens if I have a padding and I think inside the border or outside the border? This must be all consistent, right? And you have to think about, what they do on their content and that is consistent with whatever content you have. But one of the most interesting things that I had here was actually when you have a border, if you want to do fancy borders like this, then the content actually slips out. I keep drawing outside of the border. So you have actually to mask it and so on. These are technical things, but it's quite interesting to implement. Anyway, so you have basically a container, inside a container, inside a container, inside a container, until you get to the actual element. And every time you call this function, you basically are passing the widget as the first content and then putting it in, when you initialize your class, you put it inside the instance as element of the container and you go around your business. The advantage of this is that the layouting, the internal layouting of the border, of the background and so on, is done by the class container. So if you have implemented it in the class container, you just reuse it, you just add the little drawing that you want to do for that particular class and then you don't care about the rest, right? So, all right, let's go, before we close it actually, to the main application definition and see how we can actually use all this stuff, what we want to achieve. So let's take this example. Why we want to do something like that, right? So the basic idea is that now that I have this structure, what I want to do is create my application in a way very similar to HTML, right? I say I want a vertical container because my application is vertical first. There's a toolbar and there's the table here. So the toolbar stays on top and table view stays on the bottom. Within the vertical containers, I want an horizontal container, which is my first toolbar, right? The toolbar horizontally is done by a series of buttons, which we didn't see because we were at the beginning of the table. So it's only when my counter is basically greater than 0. There's the first button, right? And then I want my text input, and then I want the next series of buttons for scrolling back in steps. And then I want a standard button, which is my cache reset. And then I want my table, which is defined then again in a different way. We'll see that next time. And this is then with my modifier. So on click, scroll, padding, I add it here. Yeah, for the borders, let's see. For the borders, we can look at this. Okay. Which container first? We have borders here. No, I think they are inside the button. Here, background, paddings, and so on. So, and the modifier are just written like this. The advantage of having this is very readable, right? I can just see what's happening on the screen by taking a look at the application in one place. And this is basically, so if I run it, this is the application itself, right? It scrolls up and down, it shows the buttons and so on. I can search, and it's quite responsive. The point is, it's all defined in here. The rest is just libraries. So let me shrink it a bit so you can see the whole thing. So I have basically this layout which defines the cell inside the table, and then I have this thing that defines the rest of the application. There's no other code. And the rest is library. Of course, there is the model, which I didn't show you, which is this particular my model, which deals with the translation of comma-separated value into objects and feeding the table with it. But that's it. And on search, for example, so if I am looking at, let's take the simplest example, the buttons. If I'm looking here at the on click, right? What I say, I give it the function that should be clicked and the index that it should scroll to. That's it. So in the model, I've implemented my model-based scrolling. So it just gives a different window in the data. And I don't have to deal with UI there, just deal with deliver in a different window in the data, the different slice, and the rest is done by the widgets. I don't care about the intervals. So this is why it's so interesting to have declarative UI, because you can put together an interface like this in half an hour. You don't have to care about all the intricacy of changing the states, adding a cell, deleting a cell, and stuff like that. So there's a few things that I'm using here that are actually Python specific that are very convenient. For example, to put lists of objects, I'm using the dereferencing of a list with star. And I'm using inline ifs to make conditionals in my layout. I mean, I could program a widget that does a conditional decision for me. I can always do a container that decide if state A, then draw this, if state B, draw that, right? But if I don't have to, we use the inline ifs from Python. Same goes for producing actually lists of objects when I don't need to. So in this case, I just do a list comprehension, and then I dereference it to put it into the list of elements that I put in my container as one single list. Right? I'm just using the language. For the rest, any questions about how this is structured? Oh, here is the border. Border, background, there's it.
I'm not familiar with the concept of dereferencing lists in Python.
So I don't even know if dereference is the right term, but basically what you're doing is you transforming the list into the elements. You're putting basically the single elements into the outer context.
Okay.
It's the same as writing basically H button by itself, comma, the next, like this. But of course you cannot do a for inside the argument of the function or inside the list itself.
Yeah.
So what you can do though is you can do the for inside the list, because this is a list comprehension for Python, then put a star on top of it, and that's basically transform the list back into its constituents. Right?
Okay, yeah.
It's a neat trick to put a lot of stuff together. I mean, I could have defined my list outside and then, or could have defined more containers, like one container for this part, one container for this part, and so on, so that I could composite them. This is actually very good.
The on-click and all of that stuff is from one of the libraries, right?
Sorry?
The on-click and some of the other functions are from one of the libraries, right?
The on-click is implemented in this library, in the one that we will write together.
Okay.
I already written it, but we'll analyze it together.
Okay.
The basic event, so if you're curious about this, we'll see it in detail, but basically in base view, what I do when I create a view, I register all my window event using this call here, which is usually used as a decorator, but I use it directly. I register all my Windows event, and in this case is on mouse press, like this. So whenever the window experiences a mouse press, it passes to my view with click. The ×2 is just because of Retina display, so that I don't have to draw everything at 2 pieces, but draw actually a double resolution, and I put the events at the double resolution as well. So I pass the click to the window, and then the window does the tree search that we talked about. And we'll see this in detail. Right? But yeah, it's completely handled inside the layout. It has to be. It has to be because nobody else knows where I put my objects. Right? So if you guys think that this is interesting, the next two times I'm going to dig into the code, show you how these structures actually come to live, and where performance issues are there, why, how do you solve them, how do you organize the cache, and so on. If it makes sense.
Especially the cache would be interesting.
Yeah. This model looks too nice. So how to mess it up? Internationalization or left to right, right to left rendering, or what's the way to mess this niceness up that you can't use this model anymore, and that you need to need to use a different thing, and then you're back to the starting point.
So
What is needed in the real world application? What happens that this simplicity goes?
I didn't invent this, right? I mean,
No,
not taking any credit here. This is copied shamelessly from your Swift UI and other similar widgets. And what you usually have, for example, if you talk about internationalization, is left to right, right to left. The rest is pretty boring, but left to right, right to left is kind of problematic. So what you have is that this H container can actually draw in a different order depending on the locals that you are. So you have leading and trailing and not left and right and stuff like that. And the implementation for that, I didn't do it. So if you want to support internationalization, you would have to actually implement it yourself because I always draw left to right.
From right to left, you flip the entire application.
You do.
Oh, okay.
You do, and it actually makes sense, right?
Yeah.
So it's the list and then the button. Not the list, the text and then the, okay.
So
The text and then the button here. Right?
Can
Look.
this be hidden in a flip container or something like this, and that you have a flippable container, or that you have a programming by hand?
So no, you don't have to program it by hand. Basically, you pass the information, and the drawing of the container should be then locals aware, right? The container can be defined left to right in your code, but it can be drawn left to right for Western languages or Far Asian languages, but not for Middle East. Middle East it gets drawn right to left with the same piece of code. You don't have to deal with this. The buttons are conditional. So you see them here for basically until there is enough so that it warrants having a button there, right?
Okay.
So this is this thing is defined in this if. So if the current range is basically greater than 10,
Okay,
right?
that's where that comes from.
I have at least 10 elements before, then I can press -10, otherwise I can't, so I just remove the button.
Okay.
It's not probably not the best design because I probably should invalidate it and keep it there for the users to see. That's a good design pattern for UI, but I just used the if because I wanted to show how to add and remove stuff dynamically, right? So before we close, let's think about one moment about the cache and what happens here when I'm caching stuff. So what should I cache and what should I redraw when I do this? Oh, if I don't cache and redraw everything, it will look like one frame every 3 seconds.
I would say every horizontal container that's fully visible can be cached, but every container that's like only half visible needs to be redrawn.
Yes, this is actually the solution that I took. It was a quick and dirty solution. You could actually cache even the off containers
Okay.
and draw them partially. But to do that is a bit more complicated because if you want to cache something that is on screen, you just export the texture from the screen and you save it somewhere. That's it.
Okay.
Done. But if you want to draw and cache something that is partially off screen, you have to draw it in a separate frame buffer object and then take it from there, save it in memory, and then reuse it partially when you need, keeping track of how you draw it. So it's not that easy. And it's actually quite painful to do with this implementation of Python bridge to OpenGL. Plus, I'm not an expert in OpenGL, so I'm just
How does it work if you resize it horizontally? Like the caching, I mean, would
this has to
it
redraw.
still keep?
Well, good question. What can we cache here? What we cannot cache here? What do you think?
Well, since the left and the right ones are separate containers, I could keep those.
So I could keep caching this stuff,
Yes.
right? Because I draw it once already, right? I can cache this stuff. In the middle is a spacer anyway, so it's very lightweight to draw it, right? And I could cache the buttons because they don't move. But the text input, this part at least, I need to redraw. And the backgrounds, I need to redraw. So the outer cell, I need to redraw. Every container that is on top of the cell, borders, backgrounds, and so on, I need to redraw. This border, I need to redraw, right? So that means that our cache should have the same tree structure, right? So I should go and ask each element, can I cache you? Can you draw from cache? And if not, he should ask its own children, can you draw from cache? And if so, please do, then give me back the result and I'll add my stuff, right? And so on. So I'm only drawing what I need to draw at each step.
Quick question, why is, if you resize the window, why isn't it smooth? It doesn't look like, yeah.
Because I was a bit lazy with the caching.
It's not about caching, because you have to redraw, but what slows it down? Because stuff like this, at least more than 10, 20 years ago, was fast on Windows. So it's basically true type font rendering on screen. So
There's a lot of stuff going on in the background. For example, the last cell and the first cell, I never cache at all.
yes, okay.
And that means that I have to redraw this thing like 30 times. Also, I cannot draw some, this can be optimized. This is not the final optimization, but there is a lot that can be optimized because whenever I have a border, I actually use 2 different batches of drawing. Usually you should have 1 batch of drawing for everything. I mean, this is a bit technical, but what you want to have is that you have every object added to a certain point sequence of triangles, basically pass to OpenGL as a single object, then draw in the right order, right? Now I don't do that because I'm lazy. So basically when I have a border or a mask or something that has to mask the stuff behind, I just open a new batch, put everything inside, draw it with OpenGL, return, and then draw the stuff on top. Because there's also a technical reason, because otherwise stuff like this wouldn't work. The blue would drift, would actually spill out of the rounded corner. And here I need to use a stencil mask to do this. Now, if you don't know what Stencil Mask is, it's basically you have a few auxiliary buffers in OpenGL. One is the Stencil Mask, and in the Stencil Mask you can say where do you want to draw, where you don't want to draw. And if you put something there, like the rounded border, and then you draw the content, it will not draw outside of the rounded border. But then you cannot use it in a single batch with everything else, unless you do a lot of work by classifying all the levels of drawing and all the stencil at each level. So basically I would have to define the stencil buffer for every button at a certain level, and then draw in groups. One group, change the stencil buffer. Another group, change the stencil buffer. Another group, change the stencil buffer. I didn't have the nerve to implement it. So.
But what in the end is slower? Is it the text rendering?
It's
It's probably not done in Python.
the layout, actually the text layout is the only thing that I reuse from, it's called PyGLET, Piglet. And I haven't done the rendering of the fonts myself. And it's pretty slow, used like this, and that's probably what is slowing it down. Most of it is actually rendering the sprites for the fonts and transferring back to the GPU, rendering on the GPU and so on. This is what slows it down, yeah.
Is there
But it can be optimized a lot, even beyond this.
Is there a minimum size of this window?
No, I didn't implement it, so it can actually,
overlapping.
I don't think it should crash. Yeah, it went away completely. But yeah, except if I actually exaggerate, it actually does pretty nice. So you can go to this. Yeah. So when I resize, I actually invalidate the cache at the right places. Whenever my width and height for a certain element changes, that's the trick in the cache, I basically invalidate the cache itself and then redraw from self. But if inside the container, there is an object that didn't change its width and height, then I actually use the same texture that I had in my mind. And that's it. Yeah.
Could you, at some point in the next lectures, talk a little bit about caching in general in Python, because I didn't do that ever.
Well, I mean, we would see how this cache mechanism works, and I'm not an expert, but you'll see what you can learn from that.
Yeah, so I'm currently at level 0, so
Alright. So anything else?
Not really.
Alright, so the next lecture we'll dig through the basics of how the widget works, how the events works, and so on. The last lecture will go through the caching in detail and the implementation gotchas. Right? Hope it's useful.